So now we'll move on to the next part of our program, which is the Computable Knowledge Infrastructure in Action demonstrations and discussion panel. This will be moderated by Dr. Peter Emby, and he is the president and CEO of Regenstrief Institute, has a number of titles, but most relevant to us is he's Associate Director of Informatics for the Indiana CTSI and the Vice President for Learning Health Systems at Indiana University Health. And Dr. Emby has also been a longtime member of our MCBK steering committee and was present and active at that very first kickoff meeting we had 3 years ago. So Peter, thank you for agreeing to moderate this session, and I'll turn the baton over to you.
Welcome to the Knowledge Infrastructure panel, everyone. I'm Dr. Peter Emby, Professor and Associate Dean at the Indiana University School of Medicine and President and CEO of the Regenstrief Institute. I'm proud to have been involved in the MCBK effort from its early days as a member of the steering committee, and I'm honored to be moderating this panel. As you've been hearing during the conference, mobilizing computable biomedical knowledge is critical to creating a learning health system and improving health. But a key question is how we accomplish this and what does it take to mobilize knowledge? Knowledge management platforms and how they are evolving and gaining a better understanding of what it takes to actually build, implement, and leverage those platforms is going to be essential to realizing our vision for MCBK. For instance, we know that guidelines are being developed and updated every day, and there's a lot of evidence that we need to get those to be more computable in order to make them as usable and effective in advancing decision-making. But what are the standards? What are the approaches? What are the ways in which we need to work to mobilize knowledge artifacts? And what are the main obstacles to overcome in order to maximize their utility and applicability? Upstream and downstream, what does it take to build a knowledge ecosystem? And these are the questions that I'm very pleased to say our panelists are going to address today. They are some of the pioneers in operationalizing MCBK, and we're looking forward to hearing their knowledge and getting them to answer some of these critical questions. So with that, I'll pleased to start by introducing our first speaker, Dr. Lynn Brandt. Dr. Brandt is a hospital-based internist from Oslo, Norway. She is conducting research at the University of Oslo while working clinically in a local hospital in Oslo. Her research focuses on digitalization, sharing, and implementation of guidelines and their use as decision support clinical systems. This includes strategies for digital writing, structuring of content, and the use of APIs and information models like FHIR, as well as standard terminologies. She's also a founding member of Magic, a nonprofit organization that makes the Magic app available to enable a trustworthy digital ecosystem. And she's active in several bodies that promote guidelines, EBN methodology, and improved use of technology in healthcare. So I'll hand it over to Dr. Brandt.
Yes. Hello, everyone. My presentation, yes. So I'm going to talk a little bit about how structured guidelines can feed into the biomedical knowledge community and how it can aid decision support. Just a few words about the Magic Evidence Ecosystem Foundation. It's a nonprofit foundation. It has no shareholders. We get our money from grants and license fees from the software that we develop. It's founded by internists, my colleagues, and we're all part of the GRADE working group. And GRADE is a method for assessing this quality of evidence used in systematic reviews and guidelines. We do research in methods and frameworks of evidence-based medicine. We develop frameworks and software, and we also do guideline and systematic review development ourselves. We have been working with the digital evidence ecosystem for a long time, with tight collaborations with others in the same space. Magic App, which I'm going to talk a little bit about now, is authoring and publication platform for guidelines, evidence summaries, and decision aids. It has a big focus on supporting living evidence and dynamic updating, which has become a real focus area for us now in the COVID-19 situation, where some guidelines update every second day, and they need platforms to be able to support that. we had from the beginning data first, not PDF mission. We saw that creating guideline documents made them really difficult to use for decision support and in updating. And when they were feeding decision support modules in electronic medical records, they lost the connection to the mother guideline. So when the guideline was updated, the decision support modules were not updated, and we saw that as a critical point. We also put a great deal of effort into making guidelines available in all kind of formats, and also we have an extensive API. We make it so that everybody can use the recommendations and evidence profiles in journal articles and as decision support via widgets. I'll show you examples of that later. And we are very convinced that badly made guidelines would not make good decision support, no matter how cool the tech is. For us, that's a critical point. We work with methods, and we do want to facilitate trustworthy guidelines. So this is the digital evidence ecosystem that we work with. There's production of evidence, and then there's groups synthesizing it, groups creating guidance, and then there's group disseminating and implementing evidence. And a lot of times these are not the same people, so we need them to work together. And we need digital structured data to make this happen in an efficient way. We don't want people to rely on copy pasting data. Our space is in the top right corner, and here's how our tool have its place. So guidelines are written into a database and can be used to produce guideline artifacts in different kinds and shapes. And when there's new evidence, the guideline panels update the smaller things or the things that needs to be updated, and the content is automatically updated in all these formats. So this is how it looks. Many different organizations publish with us. They get their own branding, and they create and publish guidelines. This is one of the guidelines. It's the Australian guideline for COVID from the COVID task force. What you see here is a recommendation, and all recommendations are their own units. So the pod that you see can exist by itself. Data can be pulled from the API, and it can be used in any website or decision support module. All the different contents are structured. So this is a conditional recommendation that is a data point. And the text, of course, you need text in guidelines. So, but the different parts of the text is structured, and we know what it is. Underneath each recommendation, there are the research evidence. So this is the evidence that the guideline panels have collected to support their recommendation. If you go into one of them, this is a summary of evidence table. You can see that there's a comparison between remdesivir and placebo, and there's 10 outcomes that the guideline panel has deemed important. Here you only see 3 of them. You can see there's study results, an absolute effect estimate, and then the quality assessment of those estimates. And all this is written by the guideline panel, and the data is collected from various sources. Everything is put into a database. So all these things that you see here are data points that can also be pulled from our system. It's structured down into single studies. We see when we do focus groups and research with clinicians that clinicians do want to know which studies that are included in the numbers or the evidence base of the recommendations they read. They want to know if the study that they know about is included or not. And we have implemented frameworks, international global frameworks for developing guidelines. So this is what you see here. It's not like data, but it is text, and it is a structured framework that you use when you create the guideline. So we do not only care about how the guidelines are made, but also how they can be implemented. So this is example from the BMJ. They are using content as widgets. So this is their interface showing a recommendation. And then this is their interface of showing some of the evidence base, but then they implement these small links here, which opens up the evidence summary from our platform. It looks like it's in their platform, but they actually use our platform to show this. And that means that they don't have to create this whole structure themselves. And whenever things are updated, they get the updated table. Same with the recommendations. They can link directly to a recommendation that will always be updated. We do repackage information in different ways. So this is the same table as you saw, but only as a decision aid for patients and clinicians to have in a consultation, where they can look at the numbers and the certainty of individual outcomes and discuss whether or not the patient would like to receive the intervention or not, as well as graphical inputs. This is all made from the same data. We also have different ways of showing information to the authors, especially when they're making their decisions. This is, again, a graphical output that is using the same data as you saw in the tables. In addition to having all the data available, we do want guideline authors to start to think about implementation. And one of the ways that we do that is to allow them to write text to help implementers. Many guideline developers are not the same people that are implementing, but we do want them to start to think about implementing. So they get prompts in how to describe on which action and context they would like that one recommendation to be implemented. For instance, they can describe the target population and the recommended interventions and how they imagine that this could work in a workflow. We also let them add inclusion, exclusion codes and codes for the recommended intervention and interventions that are recommended against, using standard terminologies like SNOMED, ICD-10, ICPC, RX norm, ATC, the standards that you would like to include. We see that different countries have different terminology, so you can't really use only the international global ones if you want to implement things into, for instance, the Norwegian EHR systems. You need some local terminologies as well. So we support that. So this is how we work with the digital evidence ecosystem. We are helping organizations to create content of high quality with structure and data available, and then we help them implement it in different ways. That's my 10 minutes.
Excellent. Great. Well, thank you so much, Dr. Brandt. And just a reminder to everyone, as you are hearing these presentations, please send in your questions and we will address those as a group at the end. But with that, I will move us along. And it's my pleasure now to introduce Dr. Mevilia, Assistant Professor of Medicine at Harvard Medical School and Assistant Director of Semity Inc. Prior to joining Semity, Dr. Mevilia was Associate Director of Clinical Informatics at Partners Healthcare, where he helped define the strategy for and coordinating the implementation of clinical decision support with Epic at Partners. He was actively involved in decision support, knowledge acquisition, representation, curation, quality assurance, deployment, and governance. He also architected and maintained Knowledge Link, an info button that connects the partner's clinical applications to reference resources in a context-sensitive manner. He continues to actively practice medicine at the Brigham and Women's and Faulkner Hospital, and studied computer science, as well as obtaining his medical and master's in epidemiology degrees from Harvard University, and then completing his internship, residency, and fellowship training at Brigham and Women's Hospital. So pleasure to have you joining us today to share some of your expertise with us, Dr. Mavilia.
Thank you very much. It's a pleasure to be with you this afternoon. So it was an excellent presentation from Dr. Brandt, really focusing on guidelines and all the pieces that go into guideline development and distribution and dissemination. For my 10 minutes, I'd like to take a step back from that and talk about managing knowledge in a more generic sense, not necessarily limited to any one type of knowledge and nor any particular domain of knowledge. And then specifically to talk about how knowledge management software is an indispensable tool for that effort. Okay, so first I'm going to start off by talking about some of the challenges in the knowledge management domain. I'm going to try to define what I think of as a knowledge management software platform, and then go through some slides to show you how an effective platform should meet those challenges. So I think we would all agree that one of the difficult things about managing knowledge artifacts is that knowledge itself is heterogeneous. It can be imprecise, and I think if it comes down to formulas and mathematics or physics, it's very precise. But short of that, it can be at times even ambiguous. It's potentially boundless. Knowledge can really deal with any endeavor of humans. It's intricately interconnected, so pieces of knowledge work with each other and are based on each other. And it's constantly evolving. I think we all in this COVID era realize how much research has been done just in the last few months, and how constantly the data and policy implications and are changing in terms of not only how we practice medicine, but how society is actually running. So when you put all those things together, you get a very you get a formula for very high complexity, and I think that's one of the reasons why managing knowledge can be so difficult. On top of that, knowledge means different things to different people. So it's generated and summarized and represented and applied and utilized by different groups of stakeholders. And oftentimes these groups of people don't really cooperate or communicate that well, even amongst themselves, or let alone between them. So you can imagine that there are researchers that are doing the work of collecting the observations and doing experiments to learn about how coronavirus infects people and how we can treat them and prevent this disease. Then as those results get published into the literature, you can imagine professional societies taking those results up, perhaps using tools like Dr. Brandt described to create guidelines out of them, but also local and state health departments are going to be taking those results and coming up with policy statements and perhaps new laws and mandates for society. Then you have EHR implementers that may take some of those lessons learned and best practices for diagnosing and treatment and implement decision support rules. And then you have finally the frontline clinicians who will receive interruptions with short messages, alerts, and they will then interpret those in relation to a real patient in front of them and try to apply those recommendations as best that they can. Now you can imagine that when you have such highly complicated knowledge artifacts that are constantly changing and have to go through translations between stakeholders, that maintaining that, and keeping it up to date and making sure that it's valid and truthful, or true to the source is very important. It's very labor intensive and error prone. So that's where, knowledge management software platform can help out. So before we get into that, maybe it would be helpful to kind of define what is it when I talk about a knowledge artifact, what am I referring to? At SEMITI, we look at it in terms of two axes. One is the level of granularity or decomposability of knowledge. So there are unstructured things and structured types of knowledge. And also in terms of the level of detail, items, knowledge artifacts that have lots of details we consider deep. Oops, I'm going the wrong direction. There we go. So if you look at different types of knowledge artifacts, they can kind of distribute across those two axes. And an example of a unstructured or relatively shallow type of knowledge artifact would be actual files or documents, compared to the other extreme, where you have very detailed knowledge models or ontologies with definitions of the concepts and the relationships to each other in a very often detailed and computable way. The important thing to realize is that you usually are dealing with all of these at the same time, and you need to kind of meet the knowledge where it lives. And you can't wait for knowledge for an example, to be in the top right corner before you start managing it with some knowledge infrastructure software. However, over time, the knowledge platform that you're working with will hopefully help you evolve, because the knowledge as it goes to the top right quadrant becomes more and more computable. So it's fine to start with specifications of knowledge that maybe are document centric, but over time you want to be able to implement computable kind of manifestations of that knowledge. And the software platform should help you make that migration. So then what exactly is a knowledge management software platform? So I define it as a suite of integrated computer-based tools or applications and services that really support the entire knowledge engineering lifecycle. And what that means is that you need to be able to take in sources, variety of types of knowledge sources. Sometimes they are institution-based, or they may come from outside your institution. They may be licensed knowledge content, or even open source or content that you developed yourself. They need to coexist, these different types of knowledge, so that you have a place where you can collaborate, author new content, perhaps make new linkages between these knowledge assets, and then be able to search, display, query them, and then ultimately add value to the knowledge, create these new knowledge artifacts that you will then be able to export and serve a variety of like knowledge consumers, which can be things like EHRs or regional health system applications, or portals for patients to learn about illness, or even for researchers to collaborate. So an example of this would be if you took in knowledge about ARC's norm codes, and then also knowledge about insurance plan eligibility rules. These are two pieces of knowledge that are very different, but if you bring them into the same system and start connecting them together, what can come out of it is a CDS intervention that would display first, second, and third tier formulary choices for a given patient with a given condition. And that can be very useful to the clinician who's taking care of a patient with hypertension, and needs to know, well, based on that patient's insurance plan, what out of the myriad of medications I can prescribe should I prescribe as the next step. So there is, again, you bring in knowledge, you add value to it, and then you expose the knowledge for other use. So first requirement, actually, I should mention that really the first requirement number 0 is to be able to manage the breadth of knowledge from the structured to unstructured and deep to shallow. So it's important that your knowledge platform be able to deal with documents as well as with structured things like ontologies. But As well, I tend to look at knowledge as a pyramid or kind of an iceberg, where people tend to focus really at the top, the things that, the most glamorous types of knowledge, the actual alerts and reminders and pathways and so forth. But they strongly depend on layers of different types of knowledge artifacts beneath them. So CDS interventions are embedded within forms and flow sheets within an EHR. They rely on definitions of problems and medications and procedures that can be, for example, value sets or classification rules. And those value sets are making references to coded terminologies like SNOMED, ICD-10, and LOINC. And then, of course, where the software infrastructure platform plays a role is to be the place where you can manage all of those pieces that get connected together to actually make an effective knowledge application. So it includes things like the editors and the actual repository, the services for allowing different people to collaborate and validate the knowledge and so forth. So requirement number 2, provenance and metadata. I don't know exactly who is attending this conference, but I have to imagine that there's a good proportion of attendees that are under the age of 30 and may not recognize even what I'm showing here. But for their benefit, let me introduce the grandfather of Google, which is the card catalog. Without, if a knowledge management software platform can't even do what a card catalog does, which is kind of organize the contents of a repository by common metadata properties, then there really is no sense in moving any further. And it's a prerequisite for doing anything more sophisticated. And basically it's the answers to the common questions of who, what, when, where, or really from where in terms of provenance. And these are just examples of metadata properties. This is by no means an exhaustive list, and there exist actually multiple standards to deal with just metadata, let alone representation of knowledge itself. But you need to have this before you can move on to even more sophisticated requirements. Next requirement deals with versioning and lifecycle. So you may be managing a couple of these items, and versioning and lifecycle is a relatively simple thing if all you're doing is managing a handful of different types of things. Each of these may have its own kind of knowledge lifecycle, but if you're now managing all of these things because they're all interconnected and they all following a different lifecycle and they're all independently being revisioned and they're all referring to each other, well, then it becomes a pretty complicated, sophisticated tool that you will need to keep track of all those things simultaneously. So the point here is that knowledge evolves, and you need to maintain revisions of knowledge artifacts to have an audit trail or history to know how things changed, who changed them, when, and why. And these discrete lifecycle states are important to organize that work, especially with collaboration. You don't want somebody to build a CDS rule that they're going to promote to a published state when the value sets on which they are writing those rules are still being works in progress. So you have to make sure that things are kind of linked appropriately together. So next requirement is probably the most important, which is this dependency management issue, where obviously things refer to other things. I had mentioned that a CDS rule may make reference to a disease state of diabetes. However, what diabetes is defined by a value set that includes references to SNOMED codes. However, it's not a hierarchical type of set of relationships. It's usually kind of a web-like thing. And again, when you overlay that each of these items that are making reference to the other are going through their own life cycle states independently and being revisioned on their own, it becomes a true issue, a challenge. So here, the important thing to recognize is that knowledge does build upon itself, and it should be modular to promote reuse. Otherwise, what you will end up doing, and we've had this experience in the past at my partners, where you would create a definition of diabetes for one use case, and then for another, perhaps not even related to CDS, but for a quality metric reporting system or for a population health management system, you have to recreate that definition of diabetes instead of really defining it once and letting having different types of knowledge make reference to the same definition. So that
Dr. Mavilia, I apologize for interrupting, but we're running a little long. So if I could ask you to wrap it up soon. Thank you.
Sure. Okay. So I'll skip this part, which is basically how we would visualize a complicated set of artifacts, and really we focus on search and query. Here, there are two kinds of search. Lexical search is kind of based on text. Semantic search is based on querying the relationships between knowledge artifacts. The example would be, if I want to look for CDS rules that have digoxin in them, that's easy enough to do lexically. But if I want to look for CDS rules that are recommending when not to order a digoxin level, not even digoxin medication, with a certain level of evidence, then you get into semantic search. I'm going to skip this point and really go into validation and testing, because again, two types of validation and testing are important. One is structural. So when I'm creating a knowledge artifact, let's say as a patient, a test patient, and I want to enter a phone number versus a zip code versus a birth date, they're all strings. They're strings of numbers, or sometimes, but depending on the format, they're appropriate or not. Semantic validation is different. If I have a CDS rule that's saying, I'm looking at a certain caffeine level, is a very contrived example, but I set the threshold to 30 milligrams per ml. If I have the caffeine level, attached to the loin code, I can look up what the reference range of that should be, and I will find that 30 milligrams per ml is probably an order of magnitude error.
Dr. Mavilia, I'm sorry to do this because it's a fantastic talk, but we only have 15 minutes left in the session. I do want to give our other speakers a chance.
Sure. I'm sorry.
That's okay. So perhaps we could come back to this during the Q&A. Is there a final point in 30 seconds that you could wrap up?
I just want to talk about learning, which is another important thing, probably the most important aspect of it, which is that you want to make every error that you detect an opportunity to learn and prevent errors in the future. And we really want to get to the preventive side of things, but I'll stop right there.
Thank you. I really appreciate it. And again, sorry for cutting you off, because I'm sure everybody was enjoying it as much as I was, but great talk. Let me then turn to our next panelist, Dr. Flynn, Assistant Professor in the Department of Learning Health Sciences at the University of Michigan. Just very briefly, Dr. Flynn received his Doctor of Pharmacy in 1993, extensive work in computer science as a network analyst, working in the .coms, and then back to healthcare, thankfully for us. And in 2018, received his PhD from the University of Michigan School of Information, has been working there on operationalizing MCBK. So Dr. Flynn, take it away.
Great. Thank you, Dr. Emby, and thanks to my co-panelists and to everyone who's made this meeting go. Really appreciate it. Very excited to be with everyone here in the virtual MCBK 2020 meeting. Today, I want to talk about open standards for a knowledge grid that helps mobilize computable biomedical knowledge. And I was very much motivated by and enthused by comments that were made earlier today about a decentralized web approach to thinking about data and views and queries. And so imagine the future where we have infrastructure that allows us to access and use the complex knowledge that was just described to us as easy as we access and use electricity today through a knowledge grid. So to center these comments, it does help to do a little bit of definitions, because we may think differently about some of these concepts. So when I'm referring to a CBK artifact today, I'm referring to a digital object that represents biomedical knowledge in a machine-independent data structure, and therefore that data structure can be parsed and processed by different information systems. This is not a definition that I've come up with. It actually is taken from the Framework for Discovery and Identity Management for Information, which is listed there at the bottom of the screen. But I think it helps to think about CBK artifacts as digital objects in this way. So for our panel today, when we were putting this panel together, it occurred to us that at a high level, we're focusing on 4 areas that are all very relevant to CBK infrastructure. First, bringing structure to the computable biomedical knowledge itself, as in the GRADE platform. Managing the complexity of managing CBK was just discussed. I'm going to talk a little bit about standardizing CBK, standards for CBK that could drive an open infrastructure of the future. And then we have to think about being able to execute, run biomedical knowledge when it comes in an executable form, and that will be discussed next. So when we are doing our work on the Knowledge Grid open source software program, we're really focusing on externalizing computable biomedical knowledge from any given information system. Whether it's an EHR, which has a clinical focus, or an app for consumers, or a different type of application that's used in a research lab or in public health, whatever that information system is, instead of building, deeply embedding into our systems a whole variety of models and other computable biomedical knowledge in unique ways that only go for that system, we are more interested in coming up with infrastructures that make it much easier to have external computable biomedical knowledge that can be used by not only one information system, but many information systems. So this is a story about how to have standards that would help us make it easier to have external computable biomedical knowledge that can be used in a whole variety of ways, which is why this is related to the earlier comments about the decentralized web, and is in that essentially same way of thinking. So in our work, we have very decidedly and deliberately taken a dual view of CBK artifacts as resources, but also as services. And we think about the artifacts in both ways, and we try to hold ourselves accountable for that. So when we start to think about them, we think about externalized resources. We have a particular way of packaging resources that we call a knowledge object, which can hold a computable model or a whole variety of other types of CBK artifacts. And having those objects in repositories, that's where they would be as resources. But we want to then be able to access those resources and move them into the world, and have been working on another tool that we call the activator. And it does what it sounds like it does. It activates the CBK. It actually can unpack a knowledge object the way that we build them and provide a variety of services, APIs essentially, and make that computable biomedical knowledge available not just to one information system, but to many information systems. And in fact, the activator tool itself can be moved around the world and stood up quite quickly on any particular server of interest. So we can move the knowledge very close to our data sources and our information sources. And this is one of the goals that we have, is to have portable computable biomedical knowledge services that are supported by standardized computable biomedical knowledge artifacts that we call knowledge objects. So I'll talk about 2 resource specifications quickly, and I'll talk about 2 specifications related to the service side of the story. Again, we're always thinking about them both at the same time. So in the focus on resources and, again, knowledge objects, we have a conceptual knowledge object specification, and at MCBK before have presented on that. And so the 5 things on the screen that you see there, identifier, metadata, the actual payload, the actual encoded knowledge, a service description, and a deployment description, these make up our conceptual spec for a knowledge object. We've now complemented that with a specification of how to make that concrete, so a knowledge object packaging specification. And credit to folks in the digital libraries community and the digital object community for coming up with packaging specifications that we could follow in order to do this. So now we have a way to make these concrete, that's standardized, that we can share with others, and you can read a bit more about that online. Now, I want to also mention 2 service specifications, because this has been some of the main work that we've been doing over the last year since the previous MCBK annual meeting. So one thing we've been working on is an activation specification. So once you have a packaged knowledge object that conforms to the standard, that we're putting out into the world, an open standard. Then with the activator, you can essentially, conceptually drop that object into the activator and get the API running. And we want that to happen very quickly and also in a standardized way. And so we're working on an activation specification that will greatly facilitate going from resource to service, going from a file, a zip file, to an API. But that's not all. We know we have to be able to handle a whole variety of different types of CBK artifacts for all sorts of different use cases. And for that reason, we need to encounter and work with a variety of different runtimes or execution engines that can handle code in different formats: Python, Java, JavaScript, R, and many others besides. And so we're working on a runtime API specification for the activator, which will make it much easier for any particular code to be able to be executed this way and to have these types of services made rapidly available and made portable and movable throughout the world, mobilizing computable biomedical knowledge. So these specifications, we believe, are critical in an infrastructure like this, and we've been working on them over the past year quite a bit. So to wrap up my comments here, if you go back to that idea of what is a computable biomedical knowledge artifact, and I said it's a digital object, well, in that case, we're going to need, and we are working on, specifications for those digital objects. So what is the object? How to package the object? What are some metadata standards for the object? Those types of things have been central in our work now and in our collaborations with folks all throughout the movement mobilizing computable biomedical knowledge. But that's not all. Of course, as was also mentioned by our other speakers on this panel, we have to have ways of representing biomedical knowledge that are also standardized. And so knowledge structure and representation standards, lots of great work is going on in this space with FHIR, Fast Health Interoperability Resources for Evidence-Based Medicine and other things. We're very excited about that work and look forward to incorporating it into the work that we're doing on MCBK or CBK infrastructure. And then finally, the can be parsed and processed part is more on the service side, the way we look at things. And so activation, runtime specifications, how to actually use more and more different execution engines and what we're doing, or runtimes, and other implementation, deployment, and use standards are all needed at that level. And so if you think of it that way, we're looking for standards that already exist in the world and adopting them. Where we find gaps, we're trying to fill those gaps, ultimately to bring about an open infrastructure to mobilize CBK. Thank you.
Excellent. Thank you, Alan. All right. And so my pleasure then to introduce our last panelist before we have a little time for Q&A, Dr. Blackford Middleton. He's the Chief Informatics and Innovation Officer at AppRevita, which provides a platform for the democratization of healthcare data and payer and provider analytics. He's held professorships of biomedical informatics and medicine at Stanford, Harvard, and Vanderbilt universities, and executive roles at Stanford Partners and Vanderbilt. His work is focused on clinical informatics, the applied science around what the strategy and design and implementation of these solutions, and numerous leadership roles, far too many for me to mention, or we'll go into the next session. But suffice it to say, Blackford's an international leader and a thought leader, and we're really looking forward to his comments today. So Blackford, I'll turn it over to you.
Good afternoon, everybody. Pleasure to be on this panel with my good friends, esteemed colleagues, one and all. And thank you, Peter. Thank you, Chuck, Rachel, for putting this together. Very quickly, this story that you've been hearing about the encoding and appropriate creation of knowledge artifacts at the top of the stream, if you will, through their knowledge management life cycle and then into an execution and distribution environment. My part is going to be focusing on the tail end, really the knowledge dissemination and execution platform that we've created at AppRevita. We have a very similar philosophy in some ways to an open standards approach for knowledge representation and engineering, but we believe that it's actually extremely valuable to co-locate data and knowledge in the cloud as opposed to distributing knowledge objects. We distribute knowledge services. Those knowledge services can be inserted then into a variety of endpoints, such as the EHR, consumer-facing apps, and the like. But bottom line, our mission is to reduce the friction that occurs today in knowledge and data exchange across the provider and payer dyad, especially importantly right now, but also thinking about the consumer in the near-term future. Let's see. So the cloud environment we have created supports quality improvement, measurement, assessment, reporting, decision support, those kinds of things. I'll give some quick demos or pictures of that. Value-based contract administration, a very hot topic increasingly as we move toward value-based payment. And then interoperability, data transformation and exchange in the ways that you can see here. I won't dwell much on the non-clinical cases. They're just not that interesting to me. But the first one is about quality measurement. We now have a quality measure engine that can interpret CQL natively and execute upon that CQL once interpreted and assemble data sets from a wide variety of data sources, a wide variety of forms, and transform them on demand. The measure development environment allows the construction and maintenance of measures as they change value sets, or they change a parameter, or they change a clause, define, what have you. And we find that this centralization of processes for measure development, execution, and distribution can actually lead to some very significant savings. And the world is moving toward digital measures. There will still be a world of value-based chart abstracted data for measures, but increasingly all the data will be sourced digitally. The best example we have of this today is now pushing 2,800 hospitals using the AppRevita platform to submit data for accreditation by the Joint Commission. And that's been a real fun and incredible story that was rapidly adopted over about a 1.5-year time frame, hundreds of hospitals, sometimes per week. The value-based contract administration is not my area of expertise, but incredibly important and supported by measurement science, as you can imagine, as you think about how to really design, implement, and manage the shared math between a payer and provider who are working together on a value-based care contract. So we provide the infrastructure to design those contracts, to implement them, and then manage care by them with dashboards and advisories back to both the payer and to the provider. Here, for example, are some heat maps and some performance dashboards that depict, for example, performance across a variety of conditions, and all of these can be parameterized, of course. And importantly, from a clinical perspective, they can identify care gaps or financial gaps, as the case may be. But when a care gap is defined, we then can turn to the cloud-based knowledge delivery platform to implement a rule, an alert, or a care pathway onto the platform, have it interface to the record for data access and acquisition, and then to return to the workflow environment an insight in the form of a dashboard or a CDS hooks card or a Smart on Fire app or simply a web service, as the case may be. What this looks like in practice, we have been working hard on the HL7 Clinical Practice Guideline Implementation Guide as a way to characterize knowledge assets of a wide variety of different kinds, but things that can touch on all the different use cases you see here on the left. And then in practice, it can be inserted smack dab into the workflow in the context of an EMR where they have an iframe support capability or web services support or Smart and Fire, as the case may be. We can also do an application overlay. This sits on top of, beside the EHR, but presents a number of tools and services that can then be used by the clinician at the point of care, maintaining context with the record, of course, patient and provider. But the most sophisticated approach is to fully embed an application within the context of the EHR that uses the encoded logic of the clinical pathway or multiple clinical pathways to alert the user about things that have to be done or things to take note of. So here, for example, the alert shows a critically low O2 sat, and the user might wish to document the JVP. That can be done in line and recorded. There might be another alert about a low or switching to PO Lasix from IV prior to discharge. that can be done in line as soon as that alert is seen. And the clinicians this appeals to the clinicians because it gets work done in the clinical workflow, providing insights and kind of that 10 Commandments style that what we wrote about long ago. So that's a quick overview of sort of knowledge dissemination and execution in the context of delivery to a number of different endpoints. Thank you.
Thank you, Blackford. Fantastic. And thanks again to all the panelists. So actually, our leaders have told me that we've got a few extra minutes, so we will have about 10 minutes, no more, for a little bit of Q&A, and I'm happy about that. So thanks very much to Chuck and Rachel. With that, I have actually been getting some questions, and so we will dive right in. The first question, actually, there's a couple that are very similar, are pretty similar in the sense that I think people have been very motivated and excited about the platforms that have been presented. And so I'll put the question actually to all of you to just say a little bit about how people can access your platforms, whether you're making them available, and if so, how. That would be the sort of summary of a few of the questions we got. So maybe I'll let you go down the list in order of presentation, Dr. Brandt.
Yeah, so our application is online and freely available. You need a license agreement with us if you're an organization and you're going to publish guidelines. But if you just want to test it or try it out, you can just go to www.magicapp.org. And my email is in the presentation. So if you want to contact us, you can go via webpage as well, of course, and contact us, or email me if you have an organization that want to try this.
Thank you, Dr. Mavilia.
Yeah, so we at Semity have a software package called CKMS that we license. It can be installed locally on machines. It can be hosted on a cloud. And we can do some pilot kind of projects as an example that are free of charge of the license fees. But then it is a license package after that.
Excellent, thank you. Alan?
So ours is an open source software project and specifications project. So we are at www.kgrid, knowledge grid, so kgrid.org. And if you go to kgrid.org/guides, there's a getting started guide online there, and you can start using the software that we've created in just a few minutes time.
Thank you, Blackford.
And Aprovita is a for-profit entity building and maintaining software and providing support. The tools can be accessed in a sort of Chinese menu style. That is, you can just have the measure engine or just have the value-based contract engine, et cetera. So there's sort of an a la carte approach, and it's a licensing fee, a subscription fee to the platform. Then, depending upon which knowledge asset is used, those will be licensed or charged. There's also a way to market your knowledge assets. If you're a knowledge asset builder, then there's a way to put them into a Aprovita marketplace and see if people nibble and wish to execute them on the platform.
Fantastic. Next question is for Alan. A couple of sort of embedded questions here, so I'll just read it through. How would this spec for CBK artifacts and ability to activate them compare to SBML and OMEX that Herbert Sauer mentioned, and are they competitors? And then a follow-up from a library point of view, could both be supported?
Yeah, great question. I was very excited to hear about SBML and OMEX as well. So when I look and think about SBML in particular, we have created the knowledge object as a packaging spec, and we're focused on not only treating an SBML file as a resource, as was described, but also potentially, and we'd have to think about the interaction mode, getting an API there that would allow folks to interact with it in potentially different ways. But that would depend on the inputs and outputs and how to structure that. So that would be a case by case story. But the standard that we're pioneering here with the knowledge object sets us up nicely to be able to do that work. With activation in particular, we would complement SBML with additional specifications. We're using the open API method of specifying a RESTful API to work with a knowledge object. So that would be our initial approach, would be to combine those things in a knowledge object. And for the omics, I'm excited to learn about that, more about that. I'm not an expert in that, don't know enough about it to comment and compare and contrast, but I look forward to learning more so I can do that.
Excellent. Well, maybe as our last question, then it was asked for a couple of you, but I'll put it to each of you, maybe starting again with Alan and then Dr. Brandt and Blackford and Severio. So the question is about any pilots or other kinds of activities around knowledge grid components or knowledge objects and mobilizing computable knowledge specific to COVID that you can speak to in terms of anything you have underway. And I know some of you touched on this, but if you could just speak a little bit more to that. Alan, would you like to start?
Yeah, so there is a knowledge accelerator project that's been led by members in the MCBK community. And so I've been able to go to a few of their meetings. At the Knowledge Grid on our project, we haven't yet done a specific project for the COVID story, but we're certainly interested in the computable knowledge story as it relates to COVID and seeing where we can fit in the future. Thank you.
Great, Dr. Brandt.
We have several organizations that are writing their COVID guideline on our platform. And all of them are giving out all their data free of charge and available for everyone. We have said that our platform would be available to all organizations that want to write COVID guidelines with a free license. So there's more coming on.
Very good. Blackford?
I have the good fortune of helping to lead the COVID-19 consortium under the C19 Healthcare Coalition that many of you are familiar with, I'm sure, Mayo and MITRE. There's about 120 organizations that are interested in mobilizing knowledge to delivery to the front line. And it's a very open and engaged process of lots of folks building, for example, anticoagulation guidelines with the ACEP, American Society of Hematology, and others. And all those knowledge assets will be made openly available, and they can be executed in a wide variety of ways. Of course, there are vendors involved as well to help support the execution requirements.
Yeah, fantastic initiative. Thank you. Severio?
Yeah, we've been collaborating with a group at University of Utah, looking at the knowledge guidance that's been coming out of the CDC, WHO, and then filtered through the Utah and Massachusetts Department of Public Health to try to come up with a taxonomy of documents that would be applicable for a portal. And actually, there's a handful of posters that have been submitted and accepted at MCBK. So I encourage people, if they're interested, to look that up.
Fantastic. Well, I just want to thank you all again for the fantastic presentations. Really a tour de force. And again, as I said at the top, you all are on the front lines making this real and operationalizing it. So it's exciting to see the progress that's been made, even just since we had some similar presentations in previous years. The progress is remarkable. So thank you all again. Thanks very much to the attendees. And with that, I'll turn it back over to our leaders.